Okay, it's been a few weeks now since I've done a video, but today I wanted to talk about a couple of things on my mind. I'm going to discuss 8-bit AI, and I don't mean AI like AI that has the whole internet for a brain to answer all your questions. Response, how to program a opponent or a character in a game, I guess an NPC that will do things. I'm also going to talk about BASIC in general and how it's represented and my feelings on that. So I've got my system up and running here, ready to go. It's my programming system. And now I said I was done making videos for the Yeet Fighter game, and for the most part I am, but because I just programmed what would be AI in this game, I figured I would use it to make my point here. So this isn't so much an update on the game as it is how one might do this. Okay, now when you're using BASIC, you have random numbers. You can generate random numbers, and that's how all programming languages are going to give you that opportunity to generate a random number at any time. Now, an 8-bit random number is capped at 256 possible outcomes. Of course, now in this case, 0 messes with the randomizer, so we have 255, and so we want to take precautions to make sure we don't enter 0 as one of those random numbers. It can throw off the randomizer. And also processor speed, the cycles, everything that's going on in your program is to be taken into account. However many times this loop that you've programmed is happening is how many times you're going to produce a response from your random number generator. So in Atari BASIC you have RAND, which of course is random. And so you're going to hit RAND and say, give me a number. Now what I've got here, if it can even be read, I don't know if this is freaking out or what here. Sometimes my camera likes to freak out. I've got opponent up there. Okay, we've got all these numbers if R is less than or if R is greater than. Now what I've done is I've made it so that the variable R is RAND, and I'm adding 1 to every number that it spits out. That way it cannot come up with 0 as a random number. Okay, because I have to stay out of that. Now that might not be the case in whatever programming language you're using. You might be able to use something. In fact, 0 might just represent less than in your particular case. But with Atari BASIC, 0, unless they fix that bug, which I don't think they have. I don't know if it's a bug, but it's definitely something to look out for. It will mess up your randomizer. So what we have is the possibility of 255 numbers. When you're there, of course, 127.5 is half of that. Okay. So now if it was 256, then it would be 128. Or something to that effect. Okay. So we're looking at 128 would be a 50-50 chance of something happening. So if you say if less than 128 or if greater than 128, then those results should in effect be the same. And now if you're doing a 16-bit variable number, of course it's drastically higher. It's in the 32,000, 16,000. It's higher. It's much higher possibilities through the loop that you're creating. So this is with 8-bit, and it's it's pseudo random. You find that and I've noticed it seems to operate better with the rare. If you're trying to keep things rare, a low occurrence, then looking for a less than and keeping the number very low is more likely to give you less of an occurrence than if you put the number very high and have a greater than. For some reason it will still it will still seem to find that more. And so I use these. Now, okay, each of these lines represents a direction or button press. Okay, now, so let's look. If I look up here in the versus mode here, which I'm sure that's probably going to flip out. I think I might, let me see. Oh, it's holding firm. Okay. You can see if joy 0 right, if joy 1 right, and so on. Those are each setting up the variables for moving the characters. Now, when I have an opponent come on the screen, I obviously don't want joystick input to control that opponent if you're in a one-player game. And this is something that can be used for any game. But in this particular game, this is a more sophisticated situation because we have a character. This isn't Mario, where the character is going to move left until it runs into something, and then it's going to move right until it runs into something. It's not a situation where a character maybe doesn't have something to do, right? So case in point, in Mario, you're not using randomizing at all. It's just the character's on the screen, it's moving left until it runs into something, then it's moving right. That's not something you have to calculate. You don't have to use a random occurrence. But perhaps when you reach a hammer brother, maybe a randomizer is deciding how many times he throws a hammer through the air, or how many times he jumps, or something like that, because they have those extra moves. Well, we're talking about a character that can move left and right, can crouch, can jump in different directions, but also can punch, kick, sweep kick, jump kick, and do special moves. Okay, so we have lots of different special moves. So I have to create a pattern of randomizing that will make those things happen. I can't just say, just move towards the character, move away from the character, things like that. I have to try to balance things out, and I've done that. So and this is set up to where the character is difficult. The character will win, the opponent will win most of the time, and of course tweaking things changes that and it's usually the button press in this particular case that changed it. So I may attach 2 instances from that randomly chosen number for the button press, and then one of them is related to your difficulty switch. And so I might make it so if the difficulty switch is on easy, then there will be much less chance of a button press, and then if it's on hard, then it will be the way it is now, because it's somewhat difficult. So with all these different possibilities, you'd think it would be very complicated, but it's actually really not that complicated. Now I'm down here back to the randomized events. It's actually less code than if I was using, it's slightly less code than if I was using the inputs, because certain things aren't going to be related to an input. So, and this might seem like, you know, it doesn't make any sense, and it's not going to make sense unless somebody really knows the ins and outs of my code. So, but I'm just helping to explain. So R less than 11, that's telling you that if the random number is less than 11 and variable 11 is greater than 45, variable 11 would be my y-axis placeholder for the opponent character. And because the y-axis is measured from top to bottom, 0 to whatever, greater than 45 means essentially your character is standing up. They're not in the middle of a jump. Variable 20 equals 0 means they're not currently doing a move. For each of my characters, they have a variable that basically takes hold of that movement and then allows the movement to complete its process until it lets go of the character. So you're not, it makes it so if you're throwing a fireball, you don't just hit punch and then it cuts into the animation of the fireball and throws a punch or something like that. It helps to sequence out the patterns of animation for the moves. And it also gives me that variable to identify the type of collision that I want, because they're going to collide with each other, And I want to make sure that if they're doing a kick, it's different than if they're doing a punch, than if they're doing moves. Okay, so if those criteria are met, 14 equals 0, I believe that means that they're not squatting. Then variable 8 equals variable 8 plus 1. That's going to say the character is going to jump. Variable 8 would be up, the direction of up for that opponent character. And then it balances out things. It says variable 14 equals 1. That's going to start the animation for the jumping process. And then variable 6 and 7 are left and right. It zeroes them out. That doesn't mean you can't move when you're jumping. It just kind of resets the counters for both of those directions, so you're not in the middle of some kind of directions during the jump. And so you can still move when you're jumping. Okay, now, so what that's saying is there's kind of a seemingly low chance of the character jumping. But it's really not so, because as this is looping through, it's doing it a lot. And that's something I want to talk about later too when I talk about BASIC. But this isn't stuff that's happening per second. This is something that's happening closer to the millisecond counter. It's happening a lot. So it's looking through the numbers, it's looping and looping and looping constantly. And so it's going to have a number less than 11 relatively quickly. But because later on, when the variables for jumping have to meet a certain number before that actually even does anything, then sometimes it's not going to complete. And that's how it is with moving right and left and squatting more than jumping. But it makes it so that the movements of the characters are not just sheerly dominated by any kind of presence of a number from the random generator. So what I mean is, if you press right, your character doesn't just immediately start moving. It takes about a count of 4 cycles before the character will start to move. It's kind of a little buffer space in it, and that's how it is with everything. So this has to meet that same space as if a controller were moving the character. Otherwise you just have just a flurry of stuff, a big mess. It might actually seem like that. So we have the whole code from opponent A down to if H equals 0, go to stuff 0, and then underneath that would be stuff 1. Those all are controlling the random occurrence of moves from the opponent in the one-player game. So I'm going to scroll down, and when that's happening, I'm deciding where it's going to happen, because this is an example, but it's pushing my cycle count in my game. So it's going to be refined later, or possibly changed. But later on in my code is where I'm having the random number actually happen. It's not happening right there in that same loop every single time. And I think it might be happening at the beginning of the graphics. I moved it just recently, and where I move it relates to how long it takes for it to reach it. How many different modifications can happen to the numbers it produces. So down here I've got in my graphics section here, before it starts to reach out and grab graphics for the characters, R equals rand plus 1, that's grabbing the new number. And I might move that around later to somewhere else, and I might change how this is. This is just an example. So with these random numbers prepared, I'm going to give an example here of the game working. And this is my character being, attacked and fighting against the opponent without input from the second joystick. Okay, I'm going to go ahead and adjust the camera slightly here. I might zoom in just a little bit more. Yep. There we go. All right, that's slightly better. All right, so I'm going to pick the character. Now, here's one player. This would be one player with the opposite side characters. And then this would be one player. All these characters are the normal left side first person. So I'll just go ahead and pick the first character here. Now see, she's attacking me. See, she's jump kicking and punching, throwing. There, that's the special move. That's the hardest move to do in the game. She's throwing. There, she won. Okay, so the character beat me like it was nothing. I beat her that time. So there, I got a win there. Now if you look at the bottom of the screen, I actually have a round counter now that's functioning. When you win a round, the 2 digits left or right of the count of the timer says 1 to indicate that you've won a round. There we go. And I just saw the cycle count be exceeded by that flash on the screen there briefly. There, I won that one. Okay, so I just beat that opponent. Kind of having a hard time doing moves here. I have to lean over. But as you can see, the character is doing all of the moves that they'd be doing if a person was playing it themselves. He's throwing the fire attack. He's doing special moves, punches and kicks. He's jumping towards me. He's tough. He's tough. He's a tough tough opponent. See, he's I'm just going to kind of evade him here while this is going on. Now I'm Ryu evading or his name's Dragon. I need to change the music. There's a couple of small things left to do and then this game will be finished. But there we go. Now he won. Now it's going to go back to the title screen because I lost. There we go. Now the song at the beginning is finished, but the other 3 songs are just placeholder songs, and I'm going to go in there and chisel out some better music for each of the levels. There are 8 different levels now. There are a lot of characters. But the point here is random numbers. We're talking about how to get your character to do stuff. So what you want to focus on here is, especially with 8-bit numbers, is you've got that limit of 255. You can cut it in half, and then that is about a 50-50 chance. And so if you want something to happen more in the game, then you want to change your greater than, less than for that random occurrence to match how much you want something to happen. So perhaps you want someone to shoot a whole lot. You want your bad guy on the screen to shoot a lot, all right? So the amount you want him to shoot will be more than half of the chances of the random number. So instead of saying less than or greater than 127 or 128, which would be roughly half of a chance, you might say less than 200 or less than 220 or something. And then you're really getting up there to where it's going to happen more and more. If you don't want something to happen very much, then you're going to decrease the chance. And so you might say that it's going to happen, like in the case with the jump, less than 11. Okay. Now, this can cause your system to be stressed out, and especially with your little whatever 6507, 6502. The Atari's processor, in this game especially, because it's so graphically intensive for the Atari, and there's just so many things going on, it's really stressing out the system. And so the way the game is now, there's essentially no jittering or anything like that in a normal two-player competitive fight. So two people with two controllers fighting against each other, they're not going to see anything. But once those random numbers take over and that amount of calculation is coming into play, it pushes the system. It does. It's intense for the system. So I have to figure that out and kind of chisel it out. And it has a lot to do with combining, because when you look at what's happening here, this isn't just if R is less than 11. Okay, we're done. We figured out what it's going to do. If a number meets several of those criteria, then it's going to make each of those things happen. And because it's doing that, it can push the system. It can say, I've got too much going on, too much on my plate. I'm overflowing, the stack's too full. It's not able to put the data on the screen before it's putting the graphics on the screen, and then you get rolling and jumping and jittering and flashing and all kinds of little effects from that. So for instance, if the number that the random number generator gives me is 10, well then the number is less than 11, but it's also less than 66, and it may meet also the criteria to do some of those other things. It also is less than 97, and it's less than 104. So that means that the number 10 from the random number generator, if it meets the criteria other than just the random number that's selected, also will affect every one of those happenings. Okay, and then I've got greater thans, and those help to cancel out some of those things in the same way that letting go of the joystick or letting go of the joystick button has that same effect. I have to keep that in there, otherwise it would possibly cause your character to behave more erratically than if it was being controlled by a joystick. So this has to kind of emulate joystick presses. Now I could go another way with it and have it just do moves, and that's it. But that becomes even harder to decide what to do. What this is actually doing is emulating the possible inputs of a person that's moving the directions and pushing the button on the joystick. And now it's been fine-tuned. The character will do the more difficult moves. For instance, when they do the special moves where they go all the way up and down on the screen or across the screen with kicks and punches, those are relatively difficult moves to pull off with the joystick or with the gamepad, but the math that's behind the random number is not having a problem doing it. And to get it to do that effectively is good. It's a success as far as creating random occurrences. Now, a lot of the best games we play, there are really no random occurrences happening. A game I can think of that probably has little or no random occurrences is something like Gradius, where after you've played it a few times you realize that all of the enemies are all appearing at the same time. For the most part, the shots are all seemingly firing at the same time, maybe not always. There is little or no random occurrences happening in some of those games. But then in other games, of course, it's a necessity. You have to have the possibility of something happening, but you can't have a guarantee of it happening. Otherwise, your game is boring and predictable, and most video games use random number generating to create events within the game so that it's not predictable, so that the game is varied, and and maybe sometimes after you learn how random numbers work, you might start looking at games in a different way and realize that some of them are or are not programmed very well as far as random numbers, possibilities and occurrences and events in the games happen. In role-playing games, a random number generator might decide what prize you get. In a fighting game, of course, it's going to decide what the opponent does when they're fighting against you. In a shooting game, it might decide how many times the boss shoots or where they move in their next movement. So it's always there, and it's really not that difficult to deal with. So this is kind of a taste of random numbers. You shouldn't be afraid to use them. Now, using the variable instead of the word rand is slightly less resource intensive than plugging the word rand in there every single time you do something. What this is actually doing is when rand is looked at later on in the different banks in the loop before it gets the graphics, that's when it finds that number. Then it carries that number with it through to this part of the loop. Then that number is then compared to every one of those little if statements, and it is then gathering the data for the next movements of the characters. What I'd like to do is take, and that was why I put this under its own label of opponent A. Down here with we have opponent B with the other side of the character story mode. I'd like to make a demo that then, if the title screen sits there long enough, reaches out into those two different labels and it has the computer fighting against itself. And that's what happens when you watch Street Fighter 2 and you wait a couple minutes and it starts to show the characters fighting against each other. That's the two different opponents with random number generators helping to regulate what moves they're doing against each other. So you're seeing it all the time. You just might not know what you're looking at is just an 8 or a 16-bit, 32-bit, whatever. I think I need to stress here that 8-bit is about as simple as you're going to get, and the difference between 32-bit and 64-bit is astronomical. The capability of a 32-bit processor is very, very high. I mean, it's got so much that it can do, but a 64-bit processor is astronomically more capable than a 32-bit processor. So trying to use predictive measures and random numbers and things when you get up into 32-bit and 64-bit processors, those are times when you might be actually choosing a number. For instance, just saying 100, and you're plugging that in there and saying, okay, rand is 100, and then calculating your number from that and capping it off. So just like with the possibility of something happening, you don't want it to be so drastically, ridiculously huge that you can never, use that. So, but with 8-bit numbers, 255 is an approachable number, and cutting it in half isn't difficult. And regulating, as I'm showing here, this character, now you can limit your numbers. You can say rand, and then you can put a number in there with it. You can say rand 64 plus 1, and then it's going to only contain the possibility of 64 numbers, and making sure, in this case, it stays away from 0. In this particular case, I'm fine with staying within, 255. It's such a small number. Why is that number? I'm sure most people probably already know this, but the maximum possible outcomes of an 8-bit scenario is 256 outcomes. So a way to think about it is you have 8 switches and 8 light bulbs. And if you count how many different patterns you can create with 8 switches and 8 light bulbs, there are 256 possibilities. Okay, so, and with one of those possibilities being all of the lights off, all zeros, and the other possibility might be all of those lights on. Maybe that's all Fs or something in your code. So when your processor's happening, it's actually, I guess you would call it oscillation, is how many times it's looking to see, and it ends up being, millions and millions of times. It's running through. Now with this, you can get a feel for the timing of your system when things like this is happening. You get a feel for how fast it's actually calculating and doing things, and it's very fast. It's not, obviously not 16-bit, 32-bit, 64-bit, stuff like that, but it is pretty fast. It's fast enough to where you want to regulate things, and so this isn't, in 1 second of observable time, I am saying what is a number, between 1 and 255. It's constantly looping through and grabbing a new number every time. And you can slow that down. You can change around how much it looks for it. You can actually make the randomizing happen within a bank. Usually you have to leave the bank for some calculations to happen to be able to be added and then used. So you can have inline rand enabled, which will make it so your randomizing can happen within a bank, not have to leave a bank. And it is heavy. It takes, when you look at cycle counts and how much each thing that's happening is using up your system's time, random numbers use up quite a bit of time. It can be a make or break situation for your game. You really need those random numbers, and so you need to adjust things so that they fit in there and they don't exceed your game's capabilities. For most systems, you're not going to do that. The Atari is a special system where it's very unique how it puts graphics on the screen and how long. You have no time at all to change your code and to make things update before the screen is being drawn. It's milliseconds. So all of these calculations that are happening in these banks that aren't graphics that are being painted up on the screen are tallied and calculated and put up there to make the changes happen in a inconceivably short amount of time, an invisible amount of time in between the screen refreshes while your screen is being drawn. That is not how it is with later systems, like say the Sega Genesis. The Sega Genesis, you put something on the screen, it stays on the screen until you tell it to clear the screen and put something else on the screen. It makes it considerably easier to deal with. You can have, a lot more calculations happening. You're not stressed. You're not being stressed to do that. With the Atari, it's high stress situation. You have to try to jam as many calculations in a short amount of time as possible. Refining code is essential, and brevity is essential. Getting as many things to happen in a small amount of code. So a lot of this is going to have to be adjusted and perfected, but as you can see, the random events are happening. The opponent is attacking me like it's supposed to. The story mode is happening. Okay. Okay, for the next part of this video, I want to address something. I've noticed that, when people want to learn BASIC, they look it up and they find out, that no one uses it and it's too slow and you can't make games with it and it's too limited. And, the older BASIC, maybe it's a little truer, even though there are thousands of games that are programmed in BASIC that are really good games. There's a Burger Time game that was done in BASIC that's fast and it's great. It's how you do things with it. And of course, when you're dealing with those 8-bit computers that have basic ROMs, you already have that necessary ROM. But if you make a program that's supposed to be, usable, if someone doesn't have that basic ROM and it's a game programmed in BASIC, they're not going to be able to use it. So the big difference is that modern BASIC, Visual Basic, Visual Batari Basic, things like that, even BasiEgaXorz, those are compiling something into a binary file. And so whatever system that's running, it's going to treat it the same way that it treats any binary file. It doesn't know that it was programmed in BASIC. It's going to be able to create code that runs as fast as if it was programmed any other way. Those are more like engines that are used to create things, and it uses BASIC as that construction component. But you know, with these older systems, like with this, this is an emulator of the TRS-80 Tandy Radio Shack Color Computer 1. There were 3 different color computers, and a couple little offshoots like the MC computers and stuff like that. This one is based on the first one. It was used for, I don't know, like sending data to and from farmers over the telephone. It was way before the internet, of course. And then they wanted to repurpose the system, so they said, let's turn this into a home computer. So we got that, color computers. I actually have one. Let's see, right there under the TV, that gray, you know, computer right there is a TRS-80 fully functioning color computer. I think it's got the 16K, possibly more. Now, because it has the emblem on the visible side here, the left side as you're looking at it, this is one of the originals. As they got newer, they moved the emblem to the center right here. And it has this notoriously evil chick key kind of keyboard that is just terrible. The best reason to get a color computer 2 is to get the better keyboard, because that chick key keyboard is really nasty. It's not fun or easy to program. And also maybe a good reason to use an emulator. Now, you can use an emulator, and because these all used kind of a precursor to what was widely distributed as the Microsoft Disk System, like MS-DOS, you can make programs in emulation, and if you have the right hardware, which in this case would be a 5 1/4 inch floppy, with the right setup, you could program using an emulator and then make things that would be, you can put on a 5 1/4 inch floppy, and then they'll work on your color computer. Now, I have a color computer disk drive, and it's good. It works fine. The cartridge that connects to the disk drive goes through the cartridge port where video game ROMs or the assembly ROM would go, and it has the extended color BASIC built in. So that's how you get that. Otherwise, it has the normal color BASIC, which is a little less advanced, slightly less advanced. Now, when people program in BASIC, they're often, or want to learn to program, they're deterred by the huge amount of instruction that comes along with it, and they think that, oh, I can't understand this, or I can't use this. And really, when you're programming video games, probably 80% of what are in those instruction manuals and stuff is nothing you're ever going to use. You're not going to use it to, probably not going to use it to make, mathematical circles, geometry, fill-ins. You're not going to use it to do spreadsheet or make a calculator or any of those little cute things you can do with BASIC. You're going to use it to generate random numbers and to create variables that can be used to then move graphics on the screen and to, seem to interact with each other. And that's a kind of the principle behind making these older style video games, no matter what programming language you're using. So, but when another thing on the opposite end of the spectrum, when somebody shows BASIC, everyone's seen this, the Hello World program. So what's the Hello World program? 10, print, Hello World, 20, go to 10, run. There we go. This just says Hello World infinitely, forever and ever, until you break the code and get out of it. And it's silly and sophomoric and juvenile, and I won't say it's completely useless, but it doesn't prove anything, and it's stupefying. Okay, so what do I think people should do? Well, when it comes to putting things up on the screen that are usable and getting somebody just a kind of a taste of BASIC before they decide what they might use it for, and I believe, learning BASIC is completely valid, and if you're going to use it to make games, that's a great idea. Whatever you're going to use, be creative and eccentric about it, and don't let the simplicity or universality of something as approachable as BASIC deter you or make you think that it can't be used to create, good action video games, things like that. Of course it can. Now, if you make a game on an 8-bit computer in BASIC, then it's going to be a lot more limited than if you're using some modern, good computer, like using Visual Basic or something like BasiEgaXorz or another 7800 BASIC or something. Those are made to compile your code into a binary file that's ready to go onto the system. Like I said before, the system doesn't know. It's not going, oh wait, this was programmed in BASIC, I better run really slow and suck. It doesn't care. It's getting a binary file, and if you did it right, it's going to use it just as if it was programmed in assembly and then barfed out into machine code, machine language, okay? No, BASIC is not low-level code. And this is the highest of the high level because it requires that BASIC compiler interpreter, and it requires a BASIC ROM on your system to use. But that does not exclude it from the languages used to make games. There are thousands of games made in BASIC. A lot of them are really good. What you get for the most part with these older system BASIC games is long load times, slow moving graphics, more text oriented games, less action and stuff. But even that does not exclude you from being able to make action games. So like I said, someone made Burger Time in BASIC, and you wouldn't know that it was made in BASIC if you played it. It's fast and smooth. It plays just like an arcade game, and there are ways around it. When they did the Atari BASIC on the old 80s computers, they did a 6-page horizontal page, and it basically using the ROM that's on the system as you're programming enables left and right horizontal math without having to use assembly, and it's fast enough to use to create an arcade level of game. They knew this. They weren't thinking, let's make BASIC although no one can use it. They were thinking, let's make BASIC so that people can use it to make arcade games. And so when people got into BASIC and read the book, again, there's two different ways to look at it. You can look at that instruction book, and when you realize that 80% of it is how to calculate, triangulate things, and geometry and math and calculating things, it's none of that's, when you're making a video game that's like these old screen scrolling 8-bit, shooting and punching and role-playing games and stuff, they're simple. They are pictures being told where to be put on the screen, and then you move them around. So the essentials are in the timing, the variables, and the randomizers. So if you're going to teach somebody just a simple foot in the door first thing to do, I think variables are a good, key for the door to unlock the door. And so when I do Hello World, I'm not going to do this, Hello World like this. I'm going to go new. Okay, I'm going to say 10, A equals A plus 1. Okay. I'm going to say 20, if A equals 255, then B equals B plus 1, A equals 0. We're going to say 30, if B equals 1, then go to 70. I'm just grabbing at a number here. 40, if B equals 4, then go to 80. We're going to say 50, if B equals 5, or no, we're going to say 8, then go to 90. We'll say if 60, if B equals 12, then B equals 0. Now we're going to say at 65, we're going to say, oh, it looks like I messed up 60. I'm looking at it. 60. If B equals 12, then B equals 0. We're going to say 65, because it can't be 70, because that's when I'm going to print something. Go to 100. Why? Because that's what's after 90. I already know 70, 80, and 90 are going to be taken up with something. And I don't want anything to happen automatically. So I'm going to say 70 is print. What's it going to print? Hello world. Hello world. Oh, I'll have exclamation. Okay. Now we're going to say 80. Print. I'm a Coco computer. Okay. What are we going to do with a Coco computer? Print. Use me to make programs. Okay? How about that? Alright, now 100 is going to say go to, not Gorto, go to, and I'm leaning over here to type this. Now I'm going to list this real quick. Okay. A equals A plus 1. Every time it goes to 10, it's going to tack one more onto A. If A equals 255, then B equals B plus 1, and A equals 0. So that means every time A reaches 255, B is going up 1. Well, if B equals 1, then we're going to skip 40, 50, and 60, and 65, and we're going to go down to 70 and print what it tells me to print. Then it's going to, let's see, finish. Now, actually, now that I'm looking at it, I'm talking through it, I need to put something at the end of 70. Okay, so I'm going to retype 70. Print hello world. Now I don't want it to print the other things yet. So I'm going to say go to 100. Okay, and I'm going to do that with each of these. Print I'm a Coco computer. I only want it to say one of these messages as it goes. Go to 100. We're going to say 90. Print use me to make, how about we're going to be daring. Make games. We're going to change the syntax here to games. Go to 100. There. Now we'll list it again. Okay, we've got A equals A plus 1. If it's 255, B equals B plus 1, then A equals 0. That's looping A around. It's going to loop around anyway, but I'm being sterile and clean and telling it to cancel out A when it does that. B equals 1. We're going to go down to 70 to get the message. Then we're going to go to 100 to go back up to A to add on to the variable. Once it equals 4, now we're going to go to 80. Okay. 8, we're going to go to 90. If it equals 12, it will cancel out. But then once it reaches 65, because it hasn't met those other criteria yet, it's going to go to 100, meaning it's going to skip 70, 80, and 90. So we're going to run this and just sit back. Okay. Wow, I ran the program. It's printing hello world. Wow. Okay. Now it stopped. It's still waiting. It's waiting probably the same amount of time. I'm a Coco computer. Now it's telling you that message. Now what if I want it to only say it one time? We'll change that. We'll change that. So I'll list it. Now the way to change that would be very, very easy. We're going to say 30. If B equals 1, then B equals 2. Go to 70. Okay. Now we're going to say 40 if B equals 4, then B equals 5, go to 80, 50. If B equals 8, then B equals 6, go to 90. So what this is doing is it should only say those things one time in between the timing. List again. Now let's see here. We'll wait. And it's going to take a while. This is going to take a while. The computer's sitting here wondering, oh, hello world. It just said it. Is it running endlessly on the screen? No. It's saying it. And actually, it's going to take longer because I just realized that I should have done B equals 9 for 50. It might not even get to 50 because it just reset itself. Yeah. So, okay, we'll break that real quick and fix it. Okay, so for 50, we'll say 50 if B equals 8, then B equals 9, go to 90. Now I want this to happen faster. So I'm going to say, this is easy, 20. If A equals 64, that's way less than 255, then B equals B plus 1, A equals 0. That just sped up the entire process considerably, by about 2/3. So now I'm going to run it again. Hello world. Now this is not complicated. This is not complicated, and what I'm doing is I'm using two variables as counters for every loop. I'm canceling out the variables when I'm done using them. Some people might say for A equals something. I'm not doing that. I'm canceling them out when they reach the number, but for can do that. FOR, I mean, can do that as well. But I'm being even more simple and crude and easy with doing this. And I'd rather do that. Later on, in the more advanced basics, even then speed is a big deal. So you don't want to use things that take up a lot of time. So there we go. Now if I want this to be cool, here I'll back it out here. And I'm going to just do a soft reset. And I think that should keep my stuff. Let's see. We'll see if it kept my stuff. Run. Yeah. Use me to make games. Hey, all right. Now, yes, this is, a handful more lines than just the hello world stuff, but when somebody realizes that they can use a variable and that variable has a certain amount of numbers which are possibilities, and then the variable can be started and stopped and used as a counter, that really opens up the field. Somebody could use this simple knowledge of variables and how to use them as timers and stuff, and you could use it to make a game. If you wanted to make a text game, you just got most of what you would even need to know. For games that use graphics, variables can be the XY axis of a sprite, so to speak. Now these systems don't, have sprites. Ataris kind of do. They have player graphics, and as you get later on, of course you're going to get more capabilities woven into the systems. Like with the Sega Genesis, you're giving it data for tiles and placing it on the screen. Okay. So how about that? Hello world, I'm a Coco computer. Now, I'll escape this again, I'll list the code, and yes, it was a handful of lines of code. It was more than just 10 hello world, 20 go to 10. But you learned something here. Now, if I wanted to take it even further, I won't do that in this episode, but you could add a randomizer, and then you could have the randomizer decide which one of those three statements to say. You could say if rand is less than 64, then go to 70. If rand is greater than 63, then go to 80. If rand is greater than 200, go to 90. And then it would start saying random things. It would sometimes say hello world, sometimes it'd say use me to make games, sometimes it'd say I'm a Coco computer, and you wouldn't know what it was going to say when it was going to say it, you know. But this is just creating timers for you to use. And so of course if I wanted it to say it faster, line 20 could be A equals 32. That would be twice as fast as what it's doing now. I could probably go ahead and get rid of B and then find a way to sequence everything with a for statement. But you know, I'm trying to keep it simple. So yeah, this is how I would do hello world if I was trying to help somebody to not be afraid or to think that BASIC's useless or too simple to do anything with, to show that it's actually simple and capable, I guess. Okay, now we're back to my other system here. Something I wanted to touch on today, again, this is on the theme of BASIC being useful. I think that people are confused, thinking that in the modern day BASIC is not useful, when in fact BASIC is powerful enough to do anything you want to do today. In the past, of course, with the old 8-bit or 16-bit computers, you had to deal with ROMs and compilers and RAM limitations and speed limitations. But today, again, they're more like engines that are used to compile something that's going to become a binary file. And not a BASIC file. A BASIC file you're going to have to deal with. But a binary file, the system is going to treat it the same way as it would anything that was made with assembly or any other programming language. So, like with QBASIC. QBASIC, when it first came out, it was fast and useful. But no matter what, you were coming up with a BASIC file, and that BASIC file had to have some type of interpreter to run. So if you didn't have QBASIC on your system, I couldn't give you a BASIC file from QBASIC and you just run it and be able to play it. You had to also have QBASIC. Now then they made QBASIC 64. It actually creates an executable. And that executable will run on essentially any system. It makes it a larger file because key components that are used in the interpreter are included in that executable. So, you know, it's not going to be a nice lean program, but it is a functional program. There are, there's Galaga. Someone made Galaga. It's nearly indistinguishable from the arcade. It is a nearly arcade perfect Galaga using QBASIC 64. They made a near arcade perfect Donkey Kong. And yeah, that's not as easy as you might think, even though those are, you know, kind of, you know, early 80s graphics. The timing and everything that goes with it, the graphics and the input and stuff like that, and the score keeping and everything, it's a hassle. So doing that in BASIC is not impossible, and to think that you're kind of stuck if you choose BASIC is really kind of wrong. So what I'm showing here, and this is just kind of for fun, with BasiEgaXorz, which is a Sega Genesis, Sega CD 32X basic programming environment. I'm going to show something that I came up with, part of a game that I'm working on. I'm making a girl hero altered beast game. Okay, where the characters aren't dudes, they're girls, and I'm going to have more of a female kind of theme to everything. And this is the beginnings of that. So I'm going to go to BasiEgaXorz. Here's the program itself. Okay, and I want to show you the code. Okay, I start out with a little intro that means nothing, just a place to press start. Then it goes to here. These are the tile drawing commands. Okay, and it looks extensive, like there's a lot going on there, but in code, this is tiny. Okay, what you're doing with your Genesis to make things run nice and fast and to have an easier time with it is you're making a picture with a lot of smaller pictures in it that are going to be used as tiles. And when you make that picture, you want to keep it at a usable number of colors. So you want it to be 16 colors. And you can have several, 4 or so 16 color, ending up around 64 color maximum on the screen. And that's how tile graphics are done for backgrounds and for sprites. And that's how you could actually make a screen. That's why when you're looking at one of these 8-bit or 16-bit games, you'll notice it's a lot of the same small images gathered up together to make a larger image. And that's what this is doing. Everywhere you see Draw Tiles Inc., it is a different number. Okay, and those are all grabbing up the tiles to be used. Now I have the tiles are one image. The tiles that are used to draw what I'm about to show you is one relatively small image, but it's cut into pieces, and then those pieces are a certain pixel width, pixel height to become a tile. I'm not trying to use 100 different tiles with 100 different palettes. You can't do that with the Sega Genesis. So these are all using the same palette. So if you look at the top, if you can even read that, it says load tiles BG01, and then it says palettes BG01 PAL. That's the palette for that image. And the data for it, which are you create as binary, but then you turn them into data so that the system can use them. Those are down here at the bottom. Okay, I've got right here, BG01 is a data file, and here it is. BG01, BG01 palette. So even though this looks like quite a bit of code, this is to draw and tell each of those pieces of that larger picture where to be put up on the screen. And what this does is it makes it so that if you draw a brick house, you don't have to draw 1,000 bricks. You only have to draw one brick and then tell it where to be on the screen 1,000 times. And that's kind of how tiles work. So what I did was drew this image here, and I'll go ahead and show it to you. This is the image. Okay, and it's got, these are all pieces. It's got a tree, it's got cloudy sky, the moon, it's got a statue, it's got gravestones and a fence and grass and the ground and a little stool. Some of these graphics haven't been told to be put up there yet. That'll be for later parts of the level and stuff. But what this does is it makes it so I can scroll very cleanly and quickly the entire screen. Okay, now, so I drew this in MT Paint as a bitmap, and then I used I'm a Genesis to convert the image to a 16 color Sega Genesis binary file with a palette binary file that were then renamed into data files. All you do is rename them. It's not difficult. You just rename from bin to dat or whatever. Okay, then I'm going to go into Fusion, and then this is the image that we end up having. So I'm going to go full screen into Fusion. I think it will do that for me. Yeah, there we go. So here's the image I'm creating. All the grass on the bottom are just a tile, the ground is a tile, the wall is tiles, the fence is a set of tiles. It's all overlapping tiles. I'm going to press the direction, and here it is cleanly scrolling. There's the tree. The tree is a good example of how you can vary tiles. I used the same tile for the trunk, but rather than use one that is a continuation to create the larger tree, I have one that looks like a cutoff piece of the top. And that's beginning at a second tile. And so, you know, you can do that. You can have lots of a variety of different things. I could possibly have a bent piece of the fence, or have some broken, crumbled gravestones, things like that. So there's grass, and here it's continuing, and this just loops. But what I would do then is, when I added a character that will actually be moving, the character will then control the scrolling from a center point in the screen, and then when you reach a certain level with the character, then it will go to the next screen that is an instance of the tiles that will scroll again. So it can scroll back and forth. This was done with BASIC, and it is a super precise, clean, perfect scroll. It's just 100% perfect. Maybe it's not the greatest artwork ever. This is me drawing. I'm a good pixel artist. I like it, but later on I might choose to make it maybe a little messier looking and not as clean. But yeah, this is using a 16 color image, and then cutting pieces out of that image and then placing them up on the screen in different locations. And this is how a tile background screen is done. Now for the characters, I would then put all of the tiles for the different parts of the characters on the same exact type of screen. I would probably use a 16 color palette. If you want to be more colorful with your character, you can combine 2 palettes and 2 different screens of tiles. So a game like Golden Axe comes into mind, where they have lots of the same enemies, but because they use different palettes, the enemies are different. You have gold versions and like dark shadow versions of them, and then maybe greenish colored versions of them. And that's just a simple palette change. That's all it is. It's not heavy. So yeah, I'm moving this back and forth. Okay. Now, anyone can do this. The hardest part of it is telling it here where to put everything. And then down here I've got a V blank that's going to do the screen, and then the joystick is controlling the scrolling. Okay, scrolling left and right with left and right on the joystick. And this is not complex. It's of course going to get, this would be much, much more complex the further down you go, and the more you're adding to it. But this is a relatively tiny, it's a relatively tiny file. So if I look at this as it is, let's see here. Yeah, this is 43K. All right, it's 43K, and that's tiny. That's super, super tiny. I mean, to put it into perspective, I think Super Mario Brothers might have been 32K, something like that, and they might have fit all of the graphics that would go into that game in one, something like 16 to 24, 25 color image, and then cut the pieces out. It had pipes, bricks, the Goombas, Koopas, Mario running, very simple animations and things. And so what this is, a more color, much higher resolution, fine scrolling screen, using BasiEgaXorz, a basic program to create Sega Genesis games. So yeah, now this is just, every time I have a tile put somewhere, I put this up there. And I could refine that code and put mathematical increments. I could use variables instead for the placement between the drawing. There are lots of different ways to handle this. This is the largest way, so where I can see where every single tile is and where it goes. But it's very, very small. You can do this.